there were 2 due today. And remember to look in Shobi and look at any extra hints or directions that I put up there in the assignment. Okay, so we've got 4-3. So I'm not sure if we need, well, we got triangles on our paper, so if you want, you can be looking at the slideshow. I'm just going to go through the notes, I think. And I have the slideshow here. I'll pop it up here if you want to see it. But we can get out of that. I think it takes. We're done. Oh, there was another. Oh, I forgot about that. Let's show you these. And then it might look a lot like the worksheet I have. So actually we're not at 4-3. Okay. So here's a MyMathLab problem. So find sine of 55 degrees times cosecant of 55 degrees. And don't use your calculator. We're going to use reciprocal identity. Well, cosecant is 1 over sine, so this just equals sine of 55 degrees times 1 over sine of 55 degrees. And those cancel, so you get 1. You don't need to use your calculator for that. So to use reciprocal identities. So you've got to have that memorized. Number 2, we've got sine of minus 4 pi over 3 minus 2,000 pi. Well, is 2,000 pi a multiple of 2 pi? Yes, so this just equals, so this is a multiple of 2 pi. If we take minus 1,000 times 2 pi, so we went around the circle 2,000 times. It doesn't matter. You know, this cancels out because it's a multiple of 2 pi. Then now we just have sine of minus 4 pi over 3. Well, sine is an odd function. Sine is odd, so sine of a negative is going to be the opposite of sine of a positive angle, because it's an odd function. All right, and then we draw a picture of where's 4 pi over 3. You have to be able to count in pies. Let's see. There's a 1 pi over 3, 2 pi over 3. 3 pi over 3, 4 pi over 3. Okay, so we're down here at 4 pi over 3. And sine is the y-coordinate, it's going to be negative. So, and let's look at our triangle that we drew. I think that's going to help us too. Let's just look at our triangle. But I mean, we can say that sine of 4 pi over 3 is going to be negative, and then when we take the negative of that, we're going to get positive. But 4 pi over 3 is here. That's negative square root of 3 over 2. Is square root of 3 over 2. Or I did it a different way. I said it's going to be the negative of pi over 3 sine of pi over 3. Or the negative of this. There's many ways to do that. Okay, and then another one was there, number 3, said 4 cosine of negative t minus cosine of t. Well, cosine's an even function. So this is just cosine of negative t equals cosine of t. So it's 4 cosine t and minus 1 cosine t. So you got 4 minus 1 is 3. So that would be the answer, but I think in the problem it said let cosine t equal b, let tangent equal a, all this stuff. It's going to be 3b if we let that equal b. Okay, so we have to remember the properties even and odd functions. So that's what we're using there. All right, back to 4.3. Here we are. Right triangle trigonometry. Okay. All right, so in the sketch below, the hypotenuse is labeled as P, while T is the side opposite the angle theta, and S is opposite beta. S is adjacent to theta, while T is adjacent to beta. We're just talking about. So we need to memorize, and the book tends to use A, B, and C instead of all these other things. But so if we use A, B, and C now, and this is going to be theta. Oh, if I make this theta, I better switch these to B and A. Sorry. I just want to make that theta and then for it to work out the way the book has defined. So this is so you can say SOHCAHTOA if you want to pronounce it. Or let's see, I've got it in my book here. Sine is opposite over hypotenuse. Sine of theta is opposite over hypotenuse. This is the way to remember it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and theta. Sorry. So this is A over C, B over C, A over B. And cosecant theta is going to be 1 over sine. So if you memorize this stuff and you memorize that, then that's going to be hypotenuse over opposite. So you don't have to, I just have these memorized, the reciprocal identities memorized. Secant, I know, is 1 over cosine. So that's hypotenuse over adjacent, ADJ, and cotangent is 1 over tangent, and that is adjacent over opposite. So if we fill all these in, you know, you don't need to memorize this stuff, but C over B, B over A. And you could see from the picture we drew that this is theta, opposite over hypotenuse is A over C. And I switched it around to match the book. Adjacent is B over hypotenuse is B over C. Tangent is opposite over adjacent, etc. So that's right triangles. There's another way. The book had this in it. Another funny way to remember this. Some hog took all our apples or something. Let's see. 4-3.
My grandpa told me some old hippie caught another hippie tripping on acid.
Oh, right. Okay, that's another one. I've got some old hog came around and took our apple. But, or if you want the some old hippie.
Caught another hippie tripping on acid.
Okay, whichever one you want. I'm going to write down the some old hog came around. You can use the some old hippie if you want. And took our apple. It's a way to remember this thing. Some old hog came around, took our apple. The and is not one of the letters. But, so that's the right triangle. And we're talking about a standard first quadrant angle. Okay. Okay, so next page, we're just going to set up the 6 trig functions. Oh, okay. So I said you should practice this at home. We just did this. We want for the angle, on this one, for the angle theta. So, you know, I have the filled in notes posted. Don't take the time in class to write all this down. It's just what we went over. Just have practicing with different letters. You know, sine is opposite over hypotenuse. This is theta. So opposite over hypotenuse. I'll do the first one. Sine theta then is opposite over hypotenuse. This is theta. So opposite is T, hypotenuse is P. So for any letter that you have, you should be able to do the 6 trig functions. So practice these at home. The filled in notes are posted. You can see what happens with this time in this class. So, okay, number 5. Find the value of the 6 trig functions of the figure. So now we've got actual numbers. If they give you A, I think they forgot to give you something here. B is 4. There's missing information from this triangle. And I think slide 5 probably has it on it. Yeah. This is from slide 5 and the slides that go with this. And B is 4. So we're just missing, this is theta. So we're going to find the values of the 6 trig functions in terms of theta. So first we're going to find C. Use the Pythagorean theorem. A squared plus B squared equals C squared. So we got 3 squared plus 4 squared equals C squared. That's 9 plus 16 equals C squared. So C squared is 25. Take the square root, C is 5. It's an actual positive number, so we don't have to do plus or minus 5. Okay, so C is 5. Now we can do these. So sine of theta is opposite over adjacent over hypotenuse. There we go. So sine is 3/5. Cosine is adjacent over hypotenuse, so that's 4/5. Tangent is sine over cosine, or, okay, let's just do opposite over adjacent. 3/4. Okay, and then we can just remember cosecant is 1 over sine, so just take the reciprocal, that's 5/3. Secant theta is 1 over cosine, so that's 5/4. And cotangent is 1 over tangent. We flip that fraction, it's 4/3. That's our 6 trig functions. So we use the Pythagorean theorem to find the missing side hypotenuse. Okay, and what is meant by similar triangles? For similar triangles, we have the same shape and angles, but different sides. In our lengths of the corresponding sides are in the same ratio. So if they're in the same ratio and we do opposite over adjacent, it's going to be the same. So our trig functions depend only on the size of the angle. So our trig functions will not change. The trig functions will be the same because trig functions depend on the size of the angle. Not the size of the triangle. So similar triangles will have the same values for the 6 trig functions. So, therefore, similar triangles will have the same values for the 6 trig functions. For the trig function. Okay. Okay, so we're going to draw and label a standard 45 degrees and pi over 4 radians angle. So here it is. Okay, this is supposed to be 45 degrees. So, if I just make this one and this one, this is not on the unit circle, what would C be?
1.
It's what?
1.
No, I didn't make it, if I made it in half and a half, no.
Or
It's,
2. Or, no.
okay, it's gonna be, use the Pythagorean theorem, 1 squared plus 1 squared equals
Root 2.
C squared. That's 2 equals C squared, so C is the square root of 2. I'm not on the unit triangle now. Unit circle. I'm sorry. Not on the unit circle. I'm just using 1 and 1, so it's the square root of 2, instead of being the square root of 2 over 2. So, square root of 2. This is a 45-degree angle, or pi over 4 radians. And so, if we want to find cosine of 45, and we already know what it's going to be, but it's adjacent over hypotenuse, 1 over square root of 2. So we rationalize that, because it's not simplified to keep that in the denominator, that square root of 2 over 2. Opposite, we did adjacent over hypotenuse. We made these sides had to be the same length, and then we found C. So we got a 45-degree angle. Oh, it is an isosceles triangle because it has 2 sides of equal length. So this is just a standard 45-degree triangle. Cotangent of 45 degrees.
Does it really matter that it's 45 degrees, or is that just like an arbitrary thing?
No, it does matter that it's 45 degrees.
Okay.
45-degree angle will have equal sides here.
Oh, gotcha.
So this only works for 45-degree angles to have the same side. And then I found C. Cotangent is okay. What is it? Cotangent is cosine over sine, 45 degrees. Well, what's going to be sine of 45 degrees? If we do, sine is the same thing, square root of 2 over 2. So we're going to have the square root of 2 over 2 over the square root of 2 over 2 is 1. I'm doing it this way, but I could be using the triangle. Cotangent is adjacent over opposite. Would be 1 over 1 is 1. So there's lots of ways to do these things. Okay. And then the last one, cosecant 45. Cosecant of 45 degrees. And remembering that cosecant is 1 over sine. And sine is opposite over hypotenuse, so this is hypotenuse over, anyway, hypotenuse over adjacent. Oh, I have to look back. What was cosecant? Hypotenuse over opposite. So I guess I'm used to doing, just working it from this. 1 over. I don't have these memorized. I have 1 over sine memorized, and I would find sine first, and then flip it. And you're going to get the square root of 2, but square root of 2 over 1. So you can do it more than one way. It's the square root of 2. I just use these all the time. And don't have the extra ones memorized. Okay, next page. Any questions? This is right triangle. Okay, now we're going to do the 30, 60, 90 triangle. Okay, so draw and label a 30, 60, 90 triangle. The measure of the side opposite the 30-degree angle is 1/2 the measure of the hypotenuse. And I already mentioned that today, but we've got, this is the bigger angle, should be 60, this is 30, and that's the right. And so this, if we make the hypotenuse 2, this is 1, and then we can find this missing, call it B. So using the Pythagorean theorem, 1 squared plus B squared equals 2 squared. 1 plus B squared equals 4. Subtract your 1. B squared is 3. And so we've got B is the square root of 3. So we got the square root of 3. This is the standard 30, 60, 90 triangle. So if we want to find tangent of 60 degrees, that's opposite over adjacent. Opposite is square root of 3 over adjacent is 1. Square root of 3 over 1. Square root of 3. Oh, so I'm doing this. I did this one up there. And we could find secant, but we already found that in number 7. Tangent of 30 degrees. Tangent of 30 degrees. Is opposite over adjacent. We have to go to the 30-degree angle. Opposite over adjacent, 1 over square root of 3. Rationalize the denominator times square root of 3 over 3. Square root of 3. Square root of 3 over 3. Okay? So from these right triangles, we can find all our trig functions. Okay? 2 positive angles are complements. So you need to, complements. So this is not a right, so this is a standard 30, 60, 90 triangle. You need to memorize that one and memorize the 45. And if you know the unit circle, just multiply by 2 for those. 2 positive angles are complements if their sum is 90 degrees, or pi over 2. And remember that the sum of the angles in a triangle, this is on the preliminary material, equals what?
180 degrees.
Right. If 2 angles are complement, the sine of one equals the cosine of the other. These angles are called cofunctions. More terminology. Sine and cosine are cofunctions, and that's why it's cosine. That's why the CO's in front of it. As are tangent and cotangent. That's why it's got the CO. And secant and cosecant, which is abbreviated CSC. This relationship is written as, so So if they're cofunctions, the sine of theta is cosine of 90 minus theta. Tangent of theta is cotangent of 90 minus theta. And secant theta is cosecant theta of 90 minus theta. So we can use these properties too. There's more. So we can write cosine in terms of sine. Sine of theta. Oh, wait. Oh, why did I write theta there? Sorry. Oh, there's no theta there. It's a parenthesis. 90 minus theta. Cotangent of theta would be its cofunction tangent of 90 degrees minus theta. And cosecant is secant of 90 degrees minus theta. Okay, so find a cofunction with the same value as this expression. So if we're talking about sine of 46 degrees, the sine of 46 degrees will be the same as cosine of 90 degrees minus 46. That's cosine of 44 degrees. Oops. Cotangent of pi over 2, I'll do that over here. Cotangent of pi over 12. That's good. Cotangent of pi over 12 will be tangent of pi over 2 minus pi over 12. So you can either work that out by hand, or you can just take your calculator and you can do 1/2, 1 divided by 2, minus 1 divided by 12, enter math to fraction, and it's going to be tangent of 5/12 pi. I put the pi back in. 5 pi over 12. Okay, so that's its cofunction with the same value. Again, we're just subtracting from, if it's given to us in radians, we're going to subtract from pi over 2. If it gives it to us in degrees, we're going to subtract from 90. This is going to be sine of 90 minus 58. And that's the sine of 32 degrees. And tangent of 3 pi over 8 is going to be cotangent of pi over 2 minus 3 pi over 8. And then you can do 1/2 minus 3/8 in your calculator, or you can write it as 4 pi over 8 minus 3 pi over 8. You get cotangent of pi over 8. Okay, so we didn't finish 4-3, so the worksheets that we're going to be due Tuesday will be due Thursday. 4-3. Okay, but we still have the 4-2 worksheet, unless they weren't going to be due. If they weren't going to be due till Thursday, we're fine. I'll leave them where they are. So remember, there's worksheets from Shobi. We're supposed to be doing these worksheets. through these. We see what they're doing.
Quick question for you.
Okay, let me see what's due later. I probably already have them combined. I probably don't need to change any due dates. If I do,
Okay, so you are looking for Tuesday.
oh, okay, we don't want this is due February 1st, so let's make this due There we go.
I found it, it was like, I rented mine. What's the difference? So you do recommend getting it, because I was talking to somebody else, and they said, they don't know. So he prints out notes. I like her little trick.
Oh, okay. I can't take credit for that. Please, but thanks.